So in this video, we're simplifying indices, and this is level 1, so all pretty easy, suitable for beginners. The first part of this exercise is to add, subtract, and indices and to deal with zero indexes. So let's begin. Question 1, we're asked to simplify this, leaving our answers in positive index form. So the first question goes like this: x squared times x to the power of 5. So first, we notice that the bases are the same, both are x's. And because we are multiplying these two, we can actually add the indices. So we can express it as 2 plus 5 for the power, and x to the power of 7 is the answer. X to the power 0, or rather anything to the power 0, is equal to 1. Not x to the power 1, mind you, right? It is 1, the real number 1. For question 3, we have got x to the power 5, x to the power 7. So the bases are the same, which means when we are dividing, we can subtract the power. So in this case, base x, and we go from top to bottom, 5 minus 7. So the result is negative 2 for the power. Now, because the question wants us to express in positive index form, we can simply write 1 on top of everything and express the power now as positive 2. Okay, so this is the reciprocal of x squared. So just take note that if it's negative 2, put a 1 on top and it becomes positive 2, and it's the denominator now. Question 4, we've got 2b squared times the square of 4b. So this is 4b whole squared, which means the 2 applies to the 4 as well as the b, which means 4 squared is 16, b squared is b squared, and then now focus on the coefficients. 2 times 16 is 32. Now b squared times b squared is just 2 plus 2, giving us b to the power of 4. Simplify, leaving our answers in positive index form. We have got base A, base A, base A, but multiplication means we are going to add the powers together. Division means we will subtract the power. So we can just go from left to right. 5 plus 3 minus 9. So in this case, it is just 5 plus 3, which is 8. 8 minus 9 is negative 1. So leave your answer in positive index is just 1 over the whole thing. So it's 1 over A. Now in this expression, we are squaring the entire 2p, which means the 2, the square, applies to the 2 as well as the p. Let's see how this goes. So we will immediately get 2 squared, which is 4, p squared, which is p squared. Now I like to focus on the coefficients. So 4 times 9 is 36. Now look at the p's. We've got p squared and p over here. This is actually p to the power of 1. So that is basically 2 plus 1. Now q cubed is alone, there's no other q here, so leave it as q cubed. So the final answer will therefore be 36p cubed, q cubed. Okay, so we've got 5a cubed divided by this entire expression. Now, I like writing it as a fraction. So write the entire 5a cubed over the entire 7a squared b. If you look, can we simplify 5 and 7? Not really. Now, but look at base a here. We can have 3 minus 2. So 3 minus 2 is positive 1. That's a positive index, so a is on top. Okay, or you can just cancel 2, and then what's 3 minus 2? That's 1. Okay, now b is the denominator, and it stays as the denominator. That's it. So simplify, leaving in a positive index form. Well, right here we can see there's x and x and y and y. So because we are dealing with division, we will subtract the powers. Yeah. So how will this go? So I like to look at this and say, okay, I've got a 5 minus a 1. Next, I've got a 1 minus a 2. So we will get x power 4, y to the power minus 1. But we do not want y to the power of minus 1, do we? So in order to write this as a positive index, we bring it down as a denominator. Okay, and that's the answer. So for this question, we're asked to simplify this expression right here. Now notice, anything to the power 0 is 1, yeah? But this power 0 here is not applied to the 8. It's only applied to the a. So very important. Next, this power 2 applies to the entire 2a. Plus, we have a division here. Well, I like to write, okay, so 8 to the power 0, just write it as 1. Do you have to write 8 times 1? No, just write 8. Next, what's a square of 2a? That's 4a squared. Now, then I like to get rid of this division sign and write this as a fraction. So do we have anything else to simplify? Yes, the 8 and the 4. So this becomes a 1 and this becomes a 2. So we have a numerator of 2, a squared as a denominator, and that's the answer. Here we have got x to the power 0, which we know by now it's 1. So let's see, how will the first step look like? Well, I like to write this as 1 and y squared. Next, convert this division sign to a times, but when we do that, we have to flip the fraction on the right side. What do I mean by flip? So 3 now becomes the denominator, y cubed now becomes the numerator. Next thing we will do is to simplify. In this case, it's very easy, diagonally. So you see y squared and y cubed? Well, we can cancel this y squared away, and this becomes y. In the end, it becomes y over 3. For this question, because of the parentheses here, understand the cube applies to the 2 and the x to the power of 4. Okay, let's take a look here. So 2 cubed is 8, x to the power of 4 cubed. Now, in this situation, we actually multiply the power. So in this case, it's 4 times 3, giving us 12. Well, we're multiplying by this fraction here. Why not put this as the numerator, like I've done here? Next, look at the coefficients, 8 and 64. Can we simplify that? Yeah. So 8 becomes 1, 64 becomes 8 as the denominator. Then take a look here. We've got power, we've got the same base first of all. Now we can subtract the powers, yeah? So 12 minus 4 is positive 8. Now because it's positive 8, it stays as the numerator. Here we've got this fraction divided by this fraction, answer in positive index. Well, the first thing I know I'm going to do is to convert this to a times and flip this fraction. So that means we'll change it to a times. 10 goes up, 9a squared comes down. Okay, the method I'm using here, now some people would do the diagonal simplifying, which is fine. My personal issue with this is that if there are too many numbers going on, it can get confusing, opening the door to careless mistakes. So here is an example of how I like to deal with questions. See this 3a times 10? I simply write it as 3 times 10 times a. Nothing simple. I'm not simplifying yet. Next, denominator. See this 4 times 9? Okay, I'm going to write 9 times 4. Doesn't matter. Okay, then followed by a squared. Okay. Now, what's the point of doing this? So that I can see clearly 3 and 9 will simplify to become 1 and 3. 10 and 4 will simplify to become 2, 5 and 2. Now, a and a squared, this will cancel away, giving us an a as the denominator. After that, we'll just notice that the numerator is 5, the denominator is 3 times 2, which is 6, and a is left. In this case, I'm focusing only at one pair of numbers at a time, which I feel makes me less prone to careless mistakes. Now we got something slightly fancier. Again, we will convert this to a multiplication and flip this. So here we go. Before that, I realized that we can actually do a bit of simplifying first on the right side. If you see this, x and x, they can both go away. Yeah, so it leaves us with 4 and 5y. Alright, you see y above and y below? Oh, okay. Well, you can simplify 20 and 6 as well. I didn't, but I took care of y cubed and y squared. So it's just y as the numerator and 6 as the denominator. Alright, now comes the flipping. So division now turns into multiplication, and then we flip, right? 6 now goes up, 20xy now comes down. Now, no change to the negative sign here. Next will be simplifying diagonally. In this case, the numbers are simple. So 4 and 20 will simplify to become 1 and 5. 6 and 5, nothing to do there. Okay, bear in mind the negative sign for your final answer. Numerator 1 times 6 is 6, and 5 times 5 is 25. There's only one x here, and we've got two y's, so that's y squared. And the answer is in positive index. Okay, so again, fraction divided by fraction, we will flip. So this becomes times, and then 14b goes up, 9a comes down. Okay, this is where I do not want to simplify diagonally. I know 7 and 14, b and b, 9 and 3, a and a. Sure, you can do it, but I prefer to just focus on numerators first. 3 times 14 is 42. A squared, keep it. B, keep it. 9 times 7, 63. B, keep it. A and C. Okay, now concentrate on one pair at a time. So 42 and 63, you can both divide that by, okay, divide that by 21, and you will get 2/3. Look at a squared and a. So that will cancel out to become a to the power 1, which is the numerator. B and B will cancel each other out, so B's gone. C remains as the denominator, and that's it. Again, the reason why I'm not simplifying diagonally is so that I can basically simplify pair by pair, okay, in the next step. Recommended for more complex looking questions. So here this involves changing division to times again. So let's do that. We will see if there's anything we can do first with regards to the x. Absolutely, look at this, x power 4, x. So I can just simplify that as x cubed. So now x is gone, slightly simpler. So next, division change to times and we flip this. Okay, then my favorite move is to handle the numerators first. 3 times 5 is 15, x cubed stays, y stays, 10x y cubed. Okay, now focus 15 and 10, coefficients, 15 and 10. Divide both by 5, you get 3 and 2. X cubed and x, that becomes x squared as the numerator. Y and y cubed becomes y squared as the denominator. And this is in positive index, and that's the answer. Here we've got an expression with a division sign. Before we do that, can our job be easier right off the bat? 4 and 9, nothing. A cubed BC, nothing. 8 and 3, nothing. A and c squared, nothing. So, alright. The first step will be just to convert this to a times, and we flip this fraction right here. And here we go. Division to a times, followed by 3c squared going up there, 8a coming down. Okay, next. Instead of simplifying diagonally, I'll just take coefficients 3 times 4. A cubed, c squared, 8 times 9 or 9 times 8, 9 times 8. There's an A, there's a B, and there's a C. Alright, now look at the 3 and 9, becomes 1 and 3. 4 and 8 becomes 1 and 2. A cubed and A becomes A squared. B stays below, and C squared and C turns into C above. So look at what the numerator will become, A squared C, followed by 6B. And that's the final answer. So here we've got a whole square, which means the square is applied to the negative 3, which is a positive 9. Okay, let's see how this turns into. So this is a 9, this is an x squared, this is a y squared. Okay, denominator stays the same. Now look at the coefficients. 9 and 27, write it down separately. X squared, so this is a power 2 minus power 3, yeah? This is a power 2 minus a power 1. Look at how much neater this is. Okay, 9 and 27, that's 1/3. That's a minus 1. 2 minus 1, that's a 1. Oh, a negative power here. So write this now as the denominator together with the 3. Take note, 3 here is the denominator. And the only numerator here is y. So it's just y over 3x. Okay? Denominator 3, denominator x. So here we've got a whole square and we've got division. So let's do that. What's this going to be? Division, change it to times. Okay, and then we flip. So y goes up, 4x whole square comes down. Well, I kind of skipped a step here. What's 4x whole square? That's 16x squared. That's it. Okay, anything that we can simplify here? Look at this x here. It's gone. This x squared becomes x. Okay, so life is slightly easier here. Y and y gets cancelled out. X and x gets cancelled out. So y and y gone. So our final answer has no y's at all. This x goes away. This x squared becomes x as the denominator. Okay, so 5 as the numerator, 16x as the denominator. Okay, so here's the question. Division now becomes the times. We'll flip the 12b and 5c. Next, look at 3 times 5. Okay, b squared stays, c stays. 4 times 12 times b as the denominator. Well, if you look at this, 3 and 12 can be simplified, becomes 1 and 4. Right, b squared and b cancels out. So this becomes b as the numerator. So what do we have up there? So it's 5, b, c. Denominator, 4 times 4, 16. Okay, and the b is gone. So it's just 16 as the denominator. Ooh, here we've got power 5 applied to every term over here. 4a cubed and b squared. Well, let's see how that looks like. So that, according to the calculator, 4 to the power of 5 is 1024. A cubed to the power of 5 becomes 3 times 5, that's a to the power of 15. B squared raised to the power of 5, that's b to the power of 10. 4 squared is just 16. So from here, just focus on the coefficients. 1024 divided by 16 is 64. The rest stay the same. Ooh, how convenient. Look at this. The entire expression here is raised to the power of 0, which means everything here becomes 1, as shown here. Well, this here is going to be squared every term. 6 becomes 36. X cubed becomes x to the power of 6. 6 squared, which is not 16, it is 64. X becomes x squared. Now focus on the coefficients. 36 and 64 get simplified to this. 6 minus 2 is therefore x to the power of 4. Same base, subtract the indices when you're dividing. Okay, can our life be easier right off the bat? Not really. 15, a squared, c squared. But 6 and 14 are even numbers. So if you want to, you can simplify to 3 and 7. Doesn't matter. Otherwise, the variables, no, can't be simplified. Okay, so we know we got to change division to times. And we do that flipping. So that is executed here. 14b cubed goes up. 6a comes down. Next, multiply everything on the top. So 15 times 4, a squared, b, c squared. C cubed, I mean. Everything at the bottom, 6a c squared. 6a c squared. Okay, now just use your calculator and go. 15 times 14 divided by 6. Next, look at the a's only. A squared minus a, that's a, positive 1. B stays as b. C cubed over c squared is just c. And that's it. Again, the reason why I love this way of doing is that I can focus on one thing at a time. Coefficients, a's, b's, and c's. Compared to what? Simplifying diagonally. Okay, when we are doing this, raised to the power of 10, so we have to multiply the powers here. So even though it's a fraction, the principle is still the same. Well, we just take 2/5 times 10, which is positive 4. 1/3 times 6, which is positive 2. This, at this point in time, should be quite familiar with you. When we are dividing numbers with the same bases, we subtract the powers. So it's a power 4, 4 minus 2 gets a squared. So here we've got the entire expression here raised to the power of 1/3. Well, we have to understand that power 1/3 will be applied to everything, the 27, the a cubed, and the 8. So if you recall prime factorization, 27 is also known as 3 cubed. So 3 cubed written here, a cubed, 8 is known as 2 to the power of 3. And because we are multiplying the indices, look what happens here. Power 3 times 1/3 becomes 3 to the power of 1. A cubed, this 3 multiplied with the 1/3 becomes a to the power of 1. This becomes 2 to the power of 1. And voila, nothing else to simplify. Again, we have 2/3 as the power here, and there's a reason why 27 is chosen. Let's take a look here. So 27, express it as 3 to the power of 3. Okay, and now we're going to multiply the indices. So 2/3 times 3 gives us power 2. 6 times 2/3 becomes power 4. Then from here, don't write it as 3 squared, just leave it as 9 x to the power 4. Okie dokie, we've got operations with real numbers over here with some very suspiciously familiar numbers. Okay, this is how it goes. Look at 1.44. Well, understand that we are trying to square root. So we want perfect squares, right? We're not using a calculator, so we want perfect squares. Hey, just so you know, 1.44 is also known as 144 over 100. Okay, 27 is known as 3 cubed. 125 is known as 5 to the power 3. Now what's going to happen here? Look at 144. Isn't that a perfect square? Yes, square root 144 gives us a nice 12. Square root 100 gives us a nice 10. Okay, and here we're going to multiply the indices. Power 3 will multiply with 2/3, that's 3 squared, which is 9. Okay, this is 5 squared, which is 25. Then from here, we'll apply the rules learned in primary school. When you are adding fractions, the denominators must be the same. So turn them both to denominator 50, followed by this improper fraction, and simplify, and there you go. What do you notice here first? It's that the entire expression here is raised to the power 0. That makes our life quite a bit easier, doesn't it? So we can straight away tell that the denominator is 1. So we need only focus on the numerator at the moment. So this power half will be applied to every term over here, right? So every thing over here. 9 to the power of half, a squared to the power of half, b power 4 to the power of half. Then if you're familiar, power half actually means square root. And what's the square root of 9? It's 3. We're not going to write plus minus 3, but it's 3. Okay, so 2 multiplied by half is 1. So do we have to write a power 1? No, just write it as a. So 4 times half is 2, so it's just b squared. And everything is in positive index. Alright, so we've got this raised to the power of half, which means square root. And what do you know? We've got nice perfect squares here, 25 and 4. Okay, so let's execute. Here we've got raised to the power of half. Alright, that's fine. So if you know what you're doing here, you will multiply. Okay, basically square root 25 is 5. Okay, 2 will multiply by half, which is 1. So it's x to the power 1. Square root of 4 is 2. Y power 4, this power 4 will multiply with half, giving us 2. So that's y squared as the denominator. Next, understand that 2x cubed is like the numerator. So what's 2 times 5, right? Written here. X cubed times x, which is x to the power of 4. The denominator stays as 2y squared. Okay, now this 2 and 2 will cancel out, meaning 5 is the numerator. X, anything else? No, nothing else. So x power 4, y squared stays below, and this is the final answer. Ooh, look at this. This is probably not a level 1. Level 1.5 maybe? Look at this, base 2. Okay, 8. We can write that as base 2 as well, isn't it? 2 cubed. Right, 16. Can we write that as base 2 as well? Yeah. So understand that when you're dealing with indices, it's easier to deal with same bases, right? And if you can, write them as same bases. Let's take a look. Okay, so this is 8 to the power x. So write it as 2 to cubed. And because it's raised to the power x, you will multiply them together. So now this is power 3x. Okay, 16 is to the power of 4. And therefore, the 4 will be multiplied with the power x. And look at this. We've got base 2 power 1, base 2 power 3x, base 2 power 4x. Okay, when you're multiplying, you add the indices, which means 1 plus 3x. When you're dividing, you subtract the indices. So in this case, 1 plus 3x minus 4x, written like so. Okay, simplify this then. 3x minus 4x is negative x. And that's it, simplified. Right, so we have got base 2, base 2, base 2. Well, this is nice. That's a 1 right there. So we only need to deal with this. Okay, look at this. The power here is x plus 1. Now, if you know your indices laws, you know that, okay, when you multiply with the same base, you add the indices together, which means we can work backwards. So if I've got a sum written here for the index, I can split them up by writing 2 power x times 2 power 1. After all, if you look at this, is it not x plus 1 combined together like that? Yeah. Okay, now the rest, of course, 2 to the power 0, keep it as 1. This is pretty neat. Alright, now what happens next? If you pay attention to this, this is 2 to the power x, this is 2 to the power x, and there's a subtraction here. Okay, we can factorize that. So factorize 2x, 2 power x, factorize 2 power x. Another way to think of this is this. Think of this as 2 unknowns minus 1 of the unknown. Or think of this as like, 2 strawberries. Now this 2 power x, think of it as like a strawberry. 2 strawberries minus 1 strawberry equals to 1 strawberry. If this is confusing to you, right, stick to the factorizing idea. So think of this as factorizing 2 power x out, factorizing 2 power of x out. So what's 2 minus 1? It's 1. So it's 1 2 power x. Okay, now we're going to deal with negative indices, and we're still simplifying them. Let's take a look. Okay, so 3 to the power 0, we know this is 1. Now, this is where negative indexes come in, here. Okay, so we know this is a 1. So how do we deal with this? We've got a power negative 1. Well, the power negative 1 will be positive 1 if you put a 1 on top. So it's 1 over 9. Okay, see this? Well, I can write this as 1 over 3 squared. Notice the power negative 2 becomes power positive 2. So 1 over 3 squared. What's 1 over 3 squared? 1 over 9 as well. So just use your normal addition of fractions. 1 over 9 plus 1 over 9 is 2 over 9. And that is the answer, evaluated. Okay, so let's take a look here. About negative index right here. Well, this becomes a 1. Let's take a look. If you know power half by now, it means square root, yeah? So what is square root of 9? It ends up being 3. Okay, so I've got negative 1 for the power. It becomes positive 1 when I put a 1 on top. Okay, so it's 1 over 9 now. Well, 9 to the power 0 is just 1. Okay, so from here, this looks like a 3 holes minus 1 hole, which is 2 holes. 2 holes and 1 over 9. This is where I introduced the concept of flipping to change your powers to negative. So look at this power negative 4 here. Well, how to turn that into positive 4? Well, you flip what's inside here. So instead of 1 over x, you turn it into x over 1. Well, what's x over 1? It's just x. So therefore, x to the power 4. Okay, let's have more. Alright, this power negative 5 is applied to the entire a squared. So this is how it looks like. We will multiply the indices together, minus 10. And how do we turn this negative 10 to positive 10? Put a 1 on top, and that's it, in positive index form. Here we have negative 4 as the power. So how to turn this to positive power 4? Well, we flip the insides here. So this is how it looks like. Instead of 2 over a, turn it into a over 2. And what do you know? Your negative 4 can now be written as positive 4. So understand at this point, this power 4 we apply to a as well as 2. So it's a power 4 over 16. So again, if you want to change your negative powers to positive, you flip the insides here. There are different ways to do this question. I choose to make the inside simpler to look at. So what do I mean by that? So you see this y to the power negative 2? It will be y squared if you write it as the denominator. So 2x stays as 2x up there, but this y power 2 is now the denominator, and now the power 2 is positive. Okay, notice I did nothing out here. Stays. This stays. Okay, remember, if you want to turn this power negative 3 to positive 3, what must you do? You must flip the insides. So y squared goes up, 2x comes down. Now your cube can be applied to every single number here. So y to the power 2 times, this power 2 will multiply with 3, y power 6. 2 cubed, okay, don't forget, the cube applies to the 2 as well, is 8. Please don't write 6. Okay, next, x cubed, keep it as the denominator. Ooh, look at this, the power is currently negative, which means we flip the insides, it will be positive 1/3. Let's do that. So 8 over x cubed, okay, write it as x cubed over 8. And what do you know? This power negative 1/3 becomes positive 1/3. If you recall, 1/3 is actually cube root. Well, this is power 3. Can 8 be written as power 3? Absolutely, 2 cubed. So now this becomes x and 2. Because 3 times 1/3 becomes 1. X power 1. Do we have to write x power 1? No, just write it as x. This is going to be, this power 3 will multiply with 1/3. That's 2 power 1. Do we have to write 2 power 1? No, just write it as 2. Okay, one step at a time. I'm going to make the power positive by flipping the insides. So just 125x power 6, take the entire thing, put it as the numerator, and then 64 comes down. And because there's a power 2/3 here, it would be nice if everything here can be written as powers that are multiples of 3. And what do you know? 125 has a power 3 if you write it as 5 power 3. 64, if you use prime factorization, is actually 4 to the power 3. Notice the powers are all multiples of 3 now. Okay, that's fantastic because you're now going to multiply the powers. Okay, so that becomes 5 squared, x power 4 I mean, and then 4 squared. What's 5 squared? 25. What's 4 squared? 16. And there you go. So here we have a power that is a negative 1/3. Okay, so with power 1/3, it will be good to write your numbers as powers that are multiples of 3. And what do you know? 8 can be written as 2 cubed. Okay, so notice that what I did next was to turn the power to positive 1/3. How? By flipping the insides. Next, multiply the powers by 1/3. So 6 times 1/3 is 2. 3 times 1/3 is 1. Do you have to write 2 power 1? No, just write it as 2. Okay, our power here is negative 2. So what can we do? We can flip the insides, making the power positive 2. And finally, square 5 and square x. So that's 25 over x squared. Right, so this entire thing is raised to the power of 2, which means this square will apply to everything here. The 1/3, the 1/4, the a cubed, and the b power negative 2. So let's go. 1/4 whole square is 1 over 16. This, you'll multiply the powers, that's a to the power 6. You multiply powers here as well, b to the power negative 4. And in index, positive index, this is a problem, isn't it? Notice the denominator is 16. The numerator is a power 6. Well, the 16 is down there, so that's the denom, right? So b power negative 4 will join 16 down there. And now, because we have written it as the denominator, the power 4 becomes a positive 4. Hopefully you're familiar enough by now that power half is also known as square root. And look at this 81. Familiar? Square root of 81 is easy, isn't it? So let's do this. Square root of 81 is 9. Next, multiply the powers here. Negative 6 times half is negative 3. Now, we don't want to leave our answer in negative index, do we? So if m is negative 3 right now, if you write it as the denominator, it will turn into positive power 3. Ooh, this question is making life easy for us. So this entire thing is a 1, not a 0, it's a 1. So we can disregard it. And here, this is raised to the power negative 1, which means we can flip. Okay, all right. So this is just written as a 1, nothing else to do there. 9 goes up, a b power 4 comes down. Anything to simplify after that? Nope, that's the final answer. Okay, this is the division sign, but what I like to do is to write this as a fraction. And another thing, this power negative 1 is applied only to y, not to that 2. Okay, very important detail right there. So let's take a look here. Well, this y, if you write it as a denominator, that negative 1 becomes positive 1. Okay, this looks nice. Now remember in primary school how when you have this division, change to times, then you flip this, y over 2. Okay, what's 1 times y over 2? That's y over 2. Finished. Okay, a few things to take note here. Power negative 2 is applied to the 4 as well as the a. So let's do this. So this 4 to the power negative 2, a to the power of negative 2. So you can write this as 1 over 4 square. So that the negative 2 becomes positive 2. So what's 1 over 4 square? That's 1 over 16. Okay, a power negative 2. Well, we can write it as a power. Ooh, hang on. This is a multiplication, isn't it? So when you've got the same base and you've got a multiplication, you can add the indices. So it's minus 2 plus half. If you use your calculator, it will become negative 3 over 2 or negative 1.5. Do we want this? Look at this. This negative 3 over 2 is not applied to the 1 over 16, okay? It's applied only to the a. Well, if you write a as a denominator, you can write it to the power of positive 3 over 2. And that's the final answer. Now, this question looks a bit unfamiliar, but it's okay. I'll guide you through this. Now, 5 to the power negative x. Well, we can write it as 5 to the power x and write the negative 1 outside. Now, what's the point of doing this? So that I can substitute 5 power x equals to 9 right here. And what's 9 to the power of negative 1? It's 1 over 9. That's it. Okay, so here we have got this. Well, I want to write it as 5 power x, you see, so that I can sub 9 in there, right? So what is x over 2? Really, it is just 5 power x, okay, and raised to the power half. Remember, when you do this, you multiply the indices together to get x over 2, right? Okay, what's the utility of this? I can just write a 9 in there. And do you recall, power half is square root, so square root of 9 is positive 3 here. Okay, our index here is written as a sum, which means we can break it up by saying this is the same as 5 power x times 5 power 1. Because if you cover this, look at this. How would you simplify that? Same base, multiplied together, we'll just add the powers, x plus 1. So we're simply working backwards here. Okay, again, what's the use of having 5 power x? We can sub 9 in there. And therefore the answer is 45. Ooh, there isn't an unknown here, but the indices law stays the same. Look, power negative 2. Okay, if I write 1 on top, it becomes 3 to the power of positive 2. So, can we leave this? No, just write it as 9. So 1 over 9 is the answer. Okay, negative index, if we flip it, it becomes positive power 3. Let's do that. So 7 over x becomes x over 7. Negative 3 becomes power positive 3. Now this cube will apply to both x and 7. So it's x cubed over 3, 4, 3. Alright, for this question, you should learn how to do one step at a time. Do things one step at a time. What do I mean by that? Okay, first, focus. I want to change that division to a multiplication. And what do? Focus on one thing at a time. The only thing I'm going to do is to change the positions here. 6 comes down, 5x power negative 3 goes up. Notice, what do I mean by one step at a time? I'm not dealing with the x power negative 3 yet. Okay? The only thing I'm doing for this first step is to change this to a times and flip this fraction. That's all. Some people try to do two things at once. Flip as well as handle the negative power. I don't recommend it. Okay, next step is where I say, alright, if x has a negative power up there, if I bring it down as a denominator, then this power becomes positive 3. So this is where I handle the negative power. Okay, well, look at this. This becomes simplified diagonally as 1 and 3. Well, that's it. 5 and 3 x cubed. Ooh, all real numbers over here. This is a perfect cube right here. This whole thing is just going to turn into a 1. Alright, let's take a look. So, we are going to turn this into 1 over 27. Well, this is a bit advanced. You can also write it as 3 to the power of negative 3. And what's cool about this, you just need to multiply the indices here. Well, this whole thing raised to the power of 0 will just produce 1. No big deal. Okay, what's negative 3 times negative 1/3? This is not a plus, by the way. You're going to multiply them together. It's just 1. So this is basically 3 power 1. Divide by 3 squared. Okay, is this not the same as writing 3 over 9? Because 3 squared is also 9, right? And this division becomes the fraction bar here. And what's 3 over 9? 1/3. Ooh, things are starting to look a bit spicy here. This is just a 1, okay? Next, I'm going to do the flipping here to turn this into a power positive 2/3. Yeah? So here, flipped, positive 2/3 power. This becomes a 1. Keep it. Alright, next. Understand that 125 can be written as 5 cubed, 64, 4 cubed, which means now you can multiply the powers together. So this 3 times 2/3 becomes 5 squared. This 3 times 2/3 becomes a 2, so it's 4 squared, minus 1 over 2 power 3. Now, if you add this in your calculator, like 25 over 16, this is 25, isn't it? Over 16 minus 1 over 8, you will get this answer straight away. Okay, pretty easy. Time for flipping. So 3 over 2x, 2x over 3. And my power has gone from negative 3 to positive 3. So now you just need to be careful. 3 is applied to the 2, to the x, to the 3. And this is the final answer. Simplify the expressions here. So this will cause me to flip 1 over a to a over 1. Now, do we have to write a over 1? No, just write it as a. This square now becomes, this negative 2 becomes positive 2. And that's it. Okay, part 2, make sure you understand that the power 0 here is only applicable to the x, not to the 2 and the y power 4. Okay, so let's take a look here. Change this into 2 raised to the power 3 is 8. 1 raised to the power 3 is 1. Multiply the powers here, that's y power 12. Okay, coefficients, 8 times 1 is 8, y power 12. That's the final answer. So part 1, we've got a few negative powers there. You see this y power negative 1? If I write it as a denominator, hey, it becomes positive power 1. See this power x power negative 3? If I write this as the denominator, the power becomes positive. Okay, now look at the 5. Any other coefficients deal with? No, just write it as 5. Okay, now take a look at this. X squared minus, okay, the powers will subtract here because it's a division. And this will cancel out basically 1 minus 1. So it becomes this. Y to the power 0 is just 1. We can ignore it. X will be positive power if it's below, written as a denominator. So 5 over x is the final answer. Next, part 2. Okay, we will do that flipping again. So power to the power of negative half. We'll just flip it. And it becomes positive power half. Now, power half, if you recall, is a square root. Okay, or in this case, just multiply the powers together. That's x squared. And what's the square root of 16? It's just 4. The key to this question is understand. First step, the power negative 4 only applies to the p, not to the 3. Okay, there's a way to write this that makes life easier. So I like to write this as, you see this 3 here? It is actually the numerator. And you see this p to the power of negative 4? It will be p to the power 4 if you write it as the denominator. Notice, I have not changed my division sign yet. I'm simply writing this in a way that looks nicer. Okay, now do that flipping. So division becomes a times. So p power 4 goes up, 3 comes down. And nothing to simplify diagonally here. Just make sure the denominators combine to become 27. And that's it. Oh, for sure, this question we will flip straight away. Okay, so flip it. Now becomes from negative 2 to positive 2. Look at the powers here. You will just multiply them, yeah? So it's just y power 10. This square here, be careful, applies to the 2 as well. do not write 2 as your answer. It becomes 4. So x cubed, you multiply the power 2, becomes x to the power 6. So negative power here, we'll do that flipping to turn into positive power 3. That's it. Now this power 3 will apply to everything here, including that 2 over there. So it's x to the power 6, and 2 to the power 3 is not 6, it is 8. Okay, look at this. I like to focus on only one thing at a time. What do I mean by that? Coefficients first. Okay, focus only on 3 and 2, 6, right? You're multiplying them together. Now, base x, let's take a look. 3 plus 4, because we're multiplying, we're going to add the indices. Next, y is also known as power 1, right? And we're going to add negative 2. Well, that's basically 1 plus negative 2. So 6, x power 7, y power negative 1. And y will be positive power 1 if you write it as the denominator. That's it. Okay, we've got a power negative 1/3. We'll do that flipping first to turn it into power positive 1/3. Next, x power 12. The powers will multiply together to become x to the power 4. Okay, and if you know your prime factorization, 1 to 5 is also known as 5 cubed. And here, the powers will multiply. 3 times 1/3 is 1. So it's just 5. Well, the first step here is to flip. Y cubed power 4 goes up. 9x squared comes down. So now it's no longer power half. Sorry, no longer power negative half, it's power half. And power half is a square root, so you will basically multiply this, y squared. You square root that 9, don't forget, it's a 3. And the powers here will multiply to become 1. So x power 1 is just x. So for this question, I like to write it as a fraction, right? Use a fraction bar. So I need only focus on numerator at the time, denominator at the time. I don't like looking at this. Okay, anyway. So look at the same base, a and a. We'll just do the normal subtraction of powers, yeah? So it's just minus half, minus half. Okay, base b, that's a positive one. Minus 1, extremely important, okay? So positive 1 minus negative 1. Well, let's work it out. Minus half is minus 1. This is going to be a positive 2. Notice b squared has a positive power. Well, a will have positive power 1 if you write it as the denominator. Alright, there are many ways to do this. I chose to do it this way. So, no change here, just write the question down. Look at what I did here. This cube will be applied to the 4. This cube will be applied to the 3, so it's a power 9. And look, I chose to take 8 and write it as 2 to the power 3. And this 2 here, this 4, sorry, I'm going to turn it to base 2 as well. Okay, and it becomes 2 to the power 6. Alright, so what is nice about this? You see this division sign here? Now when we are dividing numbers with the same base, we subtract the powers, don't we? Division, subtract the powers. Look, base 2, base 2. So it's just power 6 minus power 3. Base A, it's just power 9 minus minus 1. Careful. Power 9 minus minus 1. So we get 2 cubed, a power 10. And what's 2 cubed? It's just 8. So it's 8a power 10. Many different ways to do this. This is just one of them. Ooh, look at the ugly powers here. We've got fractions and negative fractions, but the principles are the same. Okay, so we've got the whole thing raised to the power half. What does that mean? Okay, you just multiply the powers together. Well, what's 2 times half? It's just 1, so it's g power 1. What's 3 times half? 3 over 2. h power 3 over 2. Okay, now, same principle here. Look at g here, power negative 3. Raised to power negative 1/3, multiply the fractions together. Sorry, multiply the indices together. So it's positive 1. This becomes negative half. Okay, our lives are slightly easier here now. You see this multiplication here? We're going to have the same bases, add their powers together. Okay, so this is g power 1 plus g power, this is 1 plus 1, isn't it? So now for base h, it's 3 over 2 plus negative half. So that's basically going to give us 1 whole. So this is g squared, h to the power 1, and that's it. So classic pitfalls, the 0 here only applies to the x. It doesn't mean the whole thing here turns into 1. X power 0 is 1. That means 4 is left behind. Okay, so we're going to do the flipping first. 2 over x becomes x over 2. Now the power becomes positive 2. So the only thing that's raised to power 0 here is x. So it turns into 1, the 4 remains. Alright, so I'm going to square the whole thing here, x squared over 4. And look at this 4 here. Okay, it will simplify with this denom 4 here, right? The denominator 4. So the answer therefore is x squared. Okay, raised to the power of -2. Well, we can write this as 1 over 3x whole square. And what turns out to be 9 and x squared here. Well, what do you know? This division changes to a times, and you flip this, it becomes multiply 9x squared. Now focus on the coefficients. You see the 36, multiply the 9, 3 to 4. So base x, we add the powers together when you multiply. So 5 plus 2 is therefore x to the power of 7. Alright, power to -3, let's flip that so that it becomes power positive 3. Okay, next, power 3 will be applied to everything here. So 2 to the power 3, 8, x to the power 6, and 5 power 3 is 1 to 5. So from here, simplify the coefficients 8 over 6 to 5. X power 6 will simplify if x below becomes x to the power of 5. Okay, again, this question requires you to work step by step. Yeah, don't skip steps. What do I mean by that? So I'm not converting the division to a times yet. The only thing I'm handling is this power -1 here. So how do I turn it to power +1? Just flip the insides. Okay. Now I change that division to a times. Okay, so division change to a times, and then we flip this. So basically we are flipping twice. But being careful, I'm just doing one step at a time. Okay, so from here it is just 3 times 2, which is 6. X cubed stays up there. And what do you know? 6 and 4 you can simplify to 3 and 2. Look at base x and base x here. That is basically power 3 minus power 1. That's power 2. Alright, so this square is applied to everything in there. So a few ways to do this. I chose to write b power -2 as b squared. Okay, down there. Yeah, denominator. Next, this square applies to 4, 16. This square applies to a power -2, that's -4. B now becomes b squared. And of course, I do not want this ugly a to the power -4 here. I write a to the power 4 below. Okay, at this point, I'm just focusing on the coefficients. 4 times 16 is 64. Now, look at the a's. Base a up here, base 4 down here. Or base a 4 down here. So it's 3 minus 4, isn't it? So like this. B squared, a, they cancel out. They will disappear. Or think of this as 2 minus 2. So what's 2 minus 2? 0. B to the power 0 is just 1. So b disappears completely. Okay, next. This is going to be -1. Now, do I want a to the power -1? No. I write it as the denominator, and it becomes positive power 1. So the first thing I notice here is this becomes 1 entirely, the whole thing. So that means, hey, it's just 1 divided by something. In this case, it doesn't just disappear, okay? You can't just say, oh, now I'm left with this. No, this is 1 divided by the entire whole thing. Careful. What did I do with this? So this entire thing is raised to the power -1. So it will be +1 if you put 1 on top of everything here, which is what I did here. Well, what do we do at this point? You see this division, change it to the times, and you flip this. You flip the entire thing, 4x cubed. And voila, this is the final answer. So for this, a few ways to do this. Let's see. You see this x power -3? It will be x power +3 if you write it as the numerator. So it goes from denom to numerator. That's it. Okay, what's 1 divided by this thing? Well, let's have a fraction bar, shall we? 1 over the entire thing. That's it. So here, the whole thing is raised to the power -2. We'll do that flipping. X over 5 becomes 5 over x. So positive power 2 here. Now we're going to square the 5, 25. Square the x, x squared. Ooh la la, we've got a minus sign in front here, and the power here is -1/3. So the first thing I'll do is to change it to power +1/3 by flipping the insides. So 27 goes up, x power 6 comes down. Notice the power, the negative sign here stays. Okay, 27 written as 3 cubed. Now we multiply the powers together, right? So it's just -3 over x squared. Alright, for this question, I'm going to have power 1/3 applied to everything here. Okay, the part that's raised to power 0 is not, okay, the whole thing here. It's only AB. So what that means is AB will disappear, right? This thing will become 1, but the denominator 2 stays. Yeah, so tricky. If you're not careful, it gets you in trouble. So let's have 27 be turned into 3 cubed. Why? Because then now I can multiply the powers like that. Okay, you see this a to the power -5? up there? Well, I want to turn it into a positive power 5 by shifting it as the denominator. So the 2, like I said, remains, but this entire thing AB becomes 1. So power 3 times 1/3 becomes power 1, so that's 3. Power 6 times this, okay, 6 times 1/3 becomes 2. Simplify this. Okay, so multiply this for the numerator. 3 times 3 is 9. A squared, B, written here. Denominator is still 2 and A power 5. So 9 and 2, they stay. No simplifying there. Okay, you see this 2 minus 2 and 5 becomes negative 3, doesn't it? This is 2 minus 5, so it's negative 3. But it's positive 3 as the denominator. The B stays, and that's it. Okay, for this question, let's take a look. First thing I'll do is to flip 1x over 9 turns into 9 over x. Now the power is now positive. Okay, so what's square root 9? It's 3. Okay, and this is x to the power of half. Right. So notice that this is negative half actually, because it's the denominator, right? So this is 3. Do you understand? This is now 2 minus half, which is 1.5. So it's now 3 x to the power of 1.5. So the first thing I'll do is to flip. So this goes up, this comes down. Okay, notice I'm not handling the power 0 yet. Okay, I'm just doing the flipping. Okay, now I can turn this q power 0 into 1. So it's gone. So I'm going to square that 2 turns to 4. Square that p turns to p squared. Square this 3 becomes 9. Square this p squared becomes p power 4. Anything else? Look at the base p. We can simplify that, can't we? So this becomes 4 as the numerator and p squared as the denominator. Alright, we've got a few perfect cubes there. 1, 2, 5. Actually just 1. So 5 cubed, a power 6. Next, this entire thing raised to the power 0 becomes 1. This entire thing raised to the power negative 1, just write it as 1 over 5a. So the power negative 1 becomes positive power 1. Okay, now 2/3, the power 2/3 will apply to everything here. Okay, power 2/3 apply to 6. Power 2/3 apply to the negative 3. Okay, this turns into 5 squared. Okay, a power 4 and b to the power negative 2. Okay, so isn't this 25? A to the power 4. Notice this is b power negative 2. So it will be b squared if I put it down there. And what's down there together with b squared? It is 5a. This is the denominator. From here, can you see 25 and 5? Well, we can simplify that to 5. See the base a here? It's 4 minus 1. So it's a to the power 3. And b squared alone as the denominator. Okay, so we're going to square everything there, followed by, notice what I did here. This x to the power negative 3, I wrote it as 2 over x cubed. Then, one step at a time, I'm going to square everything here. So that's a 4, x squared, y power 4. And now, see this power negative 1? I'll flip it to become x cubed over 2. Then now, one step at a time, division change to times, and now we flip this. Okay, followed by, let's have the numerator, shall we? 4 times 2 is 8, x squared, y power 4. Look at base x here. It will be simplified, won't it? So it's 8, y power 4, and x as the denominator. Okay, let's flip this. X power 6 over 64. Now the power is positive. Okay, look at this. 64 is 4 to the power 3. So now the powers are multiples of 3, which is cool. We're going to multiply 1/3. So that's x squared and 4. Lots of negative powers for this question. Let's handle the inside first. What do I mean by that? Okay, look. If a is negative up here, it will be positive down here. If b is negative up there, it's positive down there. If d is negative down there, it will be positive up there. Okay, now that's not proper English at all, but I think you know what I mean, right? So if the power is negative up here, just bring it down. It will be positive 2. If its power is negative 3 up here, bring it down. It will be positive 3. That's all. Okay, so notice now everything is nicely positive in here. Now I handle the power negative 2 out there. I'll flip this entire thing. So a squared b cubed goes up. This comes down. And now I've got a positive 2. This is when I square everything. So a squared whole square will be a power 4. This, you multiply the powers, it will be p6. This 4, you will square it, 16, c power 8, b power 4. Okay, this is definitely level 1. So I will handle this first. So think of x to the power of negative 5 as 1 over x power 5. Then now do that flipping, which is division, change to times. And what's 1 over x power 5? Okay, flip it, x power 5 over 1. And this is it. Okay, so this will just turn into 0. Okay, let's take a look. We'll flip this, 1 over 27, flip it to 27 over 1, which is 27. And this is now a positive power 1/3. Okay, 0, just turn it to 1. This is 9, isn't it? Divide by 9. Okay, so 27, you know your 3 cubed. Multiply, you get 3. So here, we'll just, times and divide. So we'll just go BODMAS, shall we? So 3 times 1 is 3, from left to right. 3 over 9 is just 1/3. And congrats, you've come to the end of handling negative indices. Let's move on to the next chapter. Well, that's a scary looking word, radical. Now, basically it means writing that square root symbol, okay? You see that? You see this thing here? This is the radical form, okay? So what do we do here? This is basically called the fifth root. Now, you know square root is power half, yeah? Cube root is power 1/3. Now, what's the fifth root then? Okay, it is just 1/5. But here we've got a p to the power of 3. So it's just 3 times 1/5, which is 3/5. Okay, so this is square root n power 6 square root. Okay, and this will multiply the powers, becomes n to the power 3. So this is the radical form with the square root symbol. Okay, so this is 3 over 2, isn't it? This is 3 over 2. Then because the bases are the same and we're multiplying, we add the powers. So it's 2.5. Sorry, 3.5. Okay, so this is the radical form. This is the exponential form. Let's see. This square root will apply to the 16, like this, and the square root will also apply to that c to the power 3. Okay, so this is a 4, and this is 3 over 2. Now at this point, you see this division sign? This is where we subtract the indices, don't we? So 4 stays, okay, but look at this. C, 3 over 2, will minus half. Because when you're dividing the same bases, the powers will be subtracted. Okay, now this gives us a 4 over 2, which basically is a square. Again, this is the radical form with the square root symbol, except this is the fifth root. So let's write it in a different way, shall we? Base 10 with a division. We can subtract the powers. So it's basically 10 to the power negative 5 here. And yes, I have gone from the radical form to the exponential form here. Okay, fifth root, I write it as to the power of 1/5. And why is this useful? Now we can simply multiply the indices. So it's a negative 1. So leave our answer in positive index. It's 1 over 10. So exponential form here. Okay, radical form here. So a to the power of 4 over 3 times a to the power of 2 over 1/3. Sorry, 2 over 3, yeah. Why? Cube root. So it's power 1/3 here. Well, we've got the same basis. We've got multiplication. We add the indices. That gives us a 6 over 3, which is 2. So the final answer is a squared. Okay, radical form, square root. Okay, now we can write this as 3 over 2, a to the power of 3 over 2, a to the power of 9 over 2. And then, well, there are many ways to do this. I decided to I decided to cube everything. So 2 cubed is just 8. Here I'm going to multiply, it's just 9 over 2. Multiply this, 27 over 2. Now I've got the same base and I'm using division. So it's just 9 over 2 minus 27 over 2. Use your calculator, you will get a nice negative 9. And I don't want a power negative 9, I want it to be positive power 9. But now it's the denominator. So we are doing the cube root of everything here. So first I'll express everything as power 3. 5 power 3, 3 power 3. Okay. Then what's the cube root going to be? If you recall, it's basically power 1/3. And it becomes a 5, minus 2, 3, and a b. However, a has a negative power here. So bring it down, a squared, and that's it. Well, different ways to do this. You can choose to do the flipping first, which I did choose to do. So I want to get rid of this negative 1 straight away. So I just flip the insides, like so. Notice, I have not done anything else. One step at a time. Okay, now this cube is applied to the negative 2, okay, which is a negative 8. This cube is applied to the m, and this is a square root, which is a power half. So it's now 5 over 2. Okay, so negative 8 stays here. Notice base m. We are doing division here, right? Therefore, I'm going to take 3 minus 5 over 2. Turns out it's a nice power half. Now, let's say the question asks for this in radical form. This is the exponential form. You would just write square root m. That's all. So exponential form, radical form. Okay, let's take a look. So cube root, write it as power 1/3 times 2. Next, base A, division. So we subtract the indices, giving us 2/3. Alright, this is basically 1 to the power of 4, so basically 1. Okay, nothing much to do there. Radical form, turn it to power 1/3, exponential form. So 8 turn to 2 cubed, and this cube root turns into power 1/3. And now we multiply the powers. This becomes 2, this becomes, okay, this becomes 1, power 1, power 2. Who cares about the divide by 1? We can disregard this already. So this is the final answer. So here we've got exponential form, radical form. Answer in the positive index form. So we've got base A, base A, base A. That's cool. So the first thing I'll do is to write this cube root as power 1/3. Then, because everything here is of the same base, I'll just say, okay, there's a multiplication here. I'm going to add the indices, minus 2 plus 1/3. There's a division after that, so I'm going to subtract the result by 1/3, right? Minus 1/3. From here, enter this into a calculator, you get this. Well, because we want a positive index, we put 1 on top, the entire thing, and this is the final answer. Basically, this is asking for your answer in exponential form. So we've got 5th root, so that's a to the power 1/5. You see that they are of the same base, division, so we subtract the powers. So that's going to be a to the power 4 over 5. How nice. Square root, perfect square, perfect square, perfect square, perfect square. Okay, that's nice. So let's have this be 6q power 2, 5p. From here, division becomes a times, flip the fraction, followed by simplifying. So 3 times 5, 15. P squared times p, p cubed. Anything else? P and q, nothing to simplify, but 15 and 6 divide by 3. And you will get this as the answer. So we've got the radical form, which is a square root here. Well, the square, first of all, will be applied to everything here. 2 squared, 4. X becomes x squared. Y power 3, y power 6. Next, square root is also known as to the power of half. Yeah. So this case, we'll turn this into x power 1, y squared. Then now you look top and top to bottom. Look at this. This becomes 2 minus 1. This becomes 6 minus 2. So we've got 4 x y power 4. Oh, I know I'm going to flip this, and I know this thing will be raised to the power of half. So let's do that. So a over b becomes b over a. Next, this becomes b squared over a squared. And this becomes a to the power half, b to the power half. Alright, next, look at this b squared and b power half. Just multiply them together like that. A squared now becomes the denominator. So from here, I'll just focus on a's. Look at the a's here. It's a half minus 2, isn't it? Half minus 2, followed by 2 plus half. Final answer, therefore, is b, 2.5 up there. Half minus 2 is just negative 1/2. And what's negative 1.5? Okay, it is positive 1.5 as a denominator. Okay, this is in the radical form. Let's write this whole thing as 20 divided by 5. The power will be 20 divided by 5. Next, base y with the division. So I know I'm going to take 20 divided by 5, which is 4, minus 1. Power 4 minus power 1. So that's power 3 as the final answer. Okay, cube root of 25, sorry, 1 to 5 by now, you should know is a 5. And cube root, also known as power 1/3, okay, gives us an a power 2 here. Then from here, same base with the multiplication, we add the powers. So it's 2 plus negative 3. So it's negative 1. Do I want to write a power negative 1? No, just write it as denominator a, and that's the answer. Okay, leaving your answer in radical form. So I want to see your final answer having that square root symbol, yeah? or fifth root or whatever. Okay, let's take a look. This is now 2 over 3. This is power 1/2. And because the bases are all the same, let's do this. 2 plus 2/3 minus 1/2. That's it. 2 plus 2/3 minus 1/2. Calculator becomes 13 over 6. You see this denominator 6 here? That's basically telling you it's the 6th root over here. And that 13 is actually p to the power of 13. This is the radical form. Okay, next. So we've got the radical form written here, cube root. And by now, negative 27, we can write that as, okay, negative 3 whole cubed. All right. And then after this, can you see what happened here? As the denominator, it is negative power 2, power negative 2. Which means if I bring it up as the numerator, it becomes positive power 2. Okay, so now this will be multiplied with the 3 becomes 1. This 1/3 will multiply with 6 becomes 2. And this square will apply to that 2 becomes 4. This square will apply to the q becomes q squared. Alright, so what's next? Negative 3 times 4, negative 12. P squared stays, q squared stays. That's it. So here I'm going to square root 49, becomes a 7. P power 6, you square root that, it becomes, okay, power half. So half of 6 is 3. Half of 8 is 4. Okay, next. See this division sign here? Change it to a times. You flip this. Notice I'm not changing any of the negative powers yet. Okay, now look at this. 7 times 2 becomes 14. B cubed stays. Look at the denominator now. 4 plus negative 1, that's positive 3. B power 6 stays. Okay, now look at the simplifying top to bottom. So this becomes a b cubed down there. Okay, 14 up here, a cubed stays, and that's it. So this power 0 applies only to AB. The square root 2 still stays. Let's take a look. Alright, power half, also known as square root. Yeah, 8, I wrote it as 4 times 2. A squared, b to the power of negative 2. Okay, now look at this. Power half is also known as square root, yeah? Okay, what's the square root of 4? Right, and then this is the square root of 2. This 2 will multiply with half, that's 1. This negative 2 will multiply with half, that's minus 1. And look at this. This square root 2 and square root 2, by the way, if you type square root 2 in your calculator, you're going to get a mess. But the good news is, they cancel out right here. We don't even have to deal with it. Okay, what's square root 2 but 4, by the way? That's 2. A power 1, write it down. B power negative 1, write it down. Now, there's only one negative power here. Okay, so put it as the denominator. So that's 2a over b. So without a calculator means they want to actually see your working. So using the laws of indices, yeah. So if you know this, base 10 divided by base 10 here, we're going to subtract the power. So it's b 10 to the power negative 5. And if you know, the fifth root here can be written from the radical form to the exponential form, okay, power 1/5. So what we do at this point is to multiply the powers together. That's a negative 1, and there we go, without the calculator. Okay, next, square root of the entire thing, but we have perfect squares here. That's good. So square root will apply to 25, 81, x power negative 2, y power 8. Then from here, this becomes a 5. This becomes a negative 1. This becomes a 9, and this becomes a 8 over 2. Okay, what's this? Negative 1. What's this? 4. And if it's a negative power up here, it will be a positive power down there. So the x, bring it down. The only thing applied to the power 0 is y. Okay, 9 still stays as 9. Okay, let's take a look. So this becomes a 9. Yeah, I got rid of the y power 0 right here. Okay. And the radical form, I change it to the exponential form. And look at this, we've got the same base. Yeah, sure. So 5 over 2 minus half, right there. So I'm going to simplify it. Becomes 4 over 2. What's 4 over 2? It's 2. Okay, now I've got power half applied to my 9, which basically is square root. So square root of 9 is 3. And x. Okay, a is raised to the power 0. The 3 still stays as 3. Okay. So, and square root of 9, that's easy. Alright, first thing I'll do is say that this a power 0 is gone, just 1. Next, square root of 9 is 3, and square root turns into half of 8, so that's a power 4. 2 times 3 becomes 6, a power negative 1. Now isn't this nice? Look at the 6 and 3, that becomes a 2. And look at this base a, minus 1 minus 4, minus 1 minus 4, that's minus 5. Final answer, bring that a power negative 5 down there. Again, perfect squares, so let's take a look here. 5 squared, okay. From here, instead of the radical form, exponential form, raised to the power of half. So now I'm just going to halve the powers, right? So 5 minus 1, 9, y power 4. And if x is negative power at the top, bring it down, it becomes positive power 1. And I'm proud to announce you have survived the entire thing. This is all for level 1 questions. Next up will be level 2. Enjoy! Take care!